Alrighty, here are your notes for section 3.6. And the topic today is solving multi-step inequalities. Alright, we solved multi-step equations in the previous unit. And so really and truly, we're not learning much new today. We're just applying all our knowledge from the previous unit and using that knowledge to solve inequalities. So I've listed out the steps. You can use these steps as a checklist that you need to go through. But again, it's very, very similar to our previous unit. So the steps are written out there for you to use as a checklist, and I'm going to go through some examples. Alright, so number 1. As I run through my checklist, the first thing it says to do is draw a line, a dotted line through the inequality. Make double sign changes. Distribute and add like terms. So here we go. 8x plus negative 2 times 7x is negative 14x plus negative 2 times negative 7 is 14 is less than 38. Notice I'm keeping everything lined up. Alright, the next step, I look for like terms, and these two are like terms. Remember, you can only add like terms. And 8x plus negative 14x would give me negative 6x. Bring down the plus 14 is less than 38. Alright, I have all the variables on one side. So now I'm going to unwrap the x by starting on the outside layer, which is get rid of this plus 14. And to get rid of a plus 14, I subtract 14 from both sides. Bring down my negative 6x. The 14 take away 14 turns into 0. Bring down the is less than, and then 38 minus 14 is 24. Divide by negative 6 on both sides. That cancels. I'll have x, but wait. Since I divided both sides by a negative, just learned yesterday that when you divide both sides by a negative, you have to take that inequality symbol and flip it. So instead of is less than, it turns into is greater than. And then 24 divided by negative 6 is negative 4. Okay, let's quickly graph it. Negative 4 goes in the middle. We count up as we go to the right. We count down or get more and more negative to the left. It's going to be hollow because there's no equal sign under it. And it's pointing to the right because we want greater than, and so I shade it to the right. I want everything greater than negative 4. And all these numbers to the right are greater. Alright, let's try number 2. Draw your dotted line. Double sign change. Distribute. Distribute. 12 is greater than. When I distribute, I'll get negative 2x plus negative 8. Hopefully you're thinking along with me, not just copying. Distribute the 4. That'll give me 4x plus negative 8. Alright, I'll bring down the 12 is greater than. I have some like terms here. Negative 2x plus 4x. Negative 2x plus 4x is positive 2x plus a negative 8 added to another negative 8. It's negative 16. Now I unwrap it. Get rid of a negative 16 by adding 16 to both sides. That gives me 28 is greater than 2x. Divide both sides by 2. Do I have to flip the symbol? Nope. I did not divide both sides by a negative. So I'm good. 28 divided by 2 is 14. Is greater than x. But wait, I don't want the x on the right side. I want it on the left. So now I have to take this and flip it over so that the x is on the left. I flip everything. All right, quickly let's graph that. 14, counting to the right, 15, 16, because it gets higher. To the left gets lower. Hollow. And then it's pointing to the left. I want x, what I color, to be less than 14. Less than goes to the left. So all of these numbers here, forever and ever, are less than 14. All right. Whoops. Let's flip the page. All right, let's take a look at number 3. Dotted line. Double sign changes, distribute. Throw a 1 there in front of the x. Here we go, 1x plus negative 5. Now distribute the negative 6. Negative 6 times 3 is negative 18. Negative 6 times 3x is negative 18x. Greater than or equal to 28. Look for some like terms. I have a 1x and a negative 18x. That's negative 17x. Negative 5 plus negative 18, those are like terms. That's negative 23. Bring down the symbol, line everything up. Now unwrap. Add 23 to get rid of a negative 23. Do it on both sides. Bring your negative 17x straight down. The negative 23 and the positive 23 turns into 0. 28 plus 23 is 51. Divide by negative 17 on both sides. Okay, we just divided both sides by a negative. So we have to take this inequality symbol and flip it over. Whenever you divide both sides by a negative, flip it. All right, and when we graph it, negative 3, negative 2, negative 1, going lower to in the other direction. This time it has a little equal sign. Since it has a little equal sign, I'm going to color it in the negative 3. And it says x is less than. Less than goes to the left. All right, number 4. Dotted line. Double sign change. Whoops, don't want that one right there. That's just a negative 3, but I do need to distribute. 5x plus negative 17 is less than or equal to, when I distribute, negative 3 times negative 4x is 12x. Negative 3 times 8 is negative 24. Now this one's a little different. I have x's on opposite sides. I don't want x's on opposite sides. I want to take care of that as soon as possible. So I'll subtract 12x. 5x minus 12x, negative 7x. Bring down the negative 17. The 12x, take away 12x, disappears. Bring down the negative 24. Okay, now unwrap it. Add 17, which takes care of the minus 17. Bring down your negative 7x. These two turn into 0. Bring down your inequality symbol. Negative 24 plus 17 is negative 7. We're almost done. Divide by negative 7. Oh, dividing both sides by a negative. Flip this over. You get x is greater than or equal to 1. My number line. x is greater than or equal to, we'll fill it in and we'll go to the right. Greater than goes to the right. Okay, we're almost done. Number 5. Dotted line, double sign change, distribute. Same thing we did in the previous unit. Negative 6 times 8, negative 48. I'm distributing. Negative 6 times 7x, negative 42x. Bring down the plus 7x. Bring down your inequality symbol. Bring everything else down. Notice I'm lining it all up. And I'm writing big enough so that I can read it. Okay, over here I have a couple like terms. So I can add like terms. I'll just bring the negative 48 down. Adding my like terms, negative 42x plus 7x would give me negative 35x. Lining everything else up. Okay, being observant. I see x is on the left, x is on the right. You cannot have x's on the left and on the right. You need to take care of that. So let's get rid of this negative 2x. Add 2x. Some of you struggled a little bit with that in the previous unit. Alright, bring down your negative 48. Negative 35x plus 2x is negative 33x. Bring down your negative 15. And then unwrap it. Opposite of subtract 48 is add 48. Do that on both sides. You'll have negative 33x is greater than, let's see, negative 15 and positive 48 would be 33. Divide by a I'm dividing by a negative. When you divide by a negative, you have to flip this inequality. Flip it over. So right now it's greater than. Make it an is less than. All right. Graphing. Negative 1, 0, 1, because I get higher and higher to the right. Lower and lower or more negative to the left. Hollow. Since it says x is less than, goes to the left. It points to the left. So all these numbers are the solutions. All right, great. One more to go. Hopefully this is helpful and you're keeping up. You can always pause the video, rewind it, and listen to it again. All right, last one. Tell whether the given number is a solution of 3x minus 5 is less than or equal to 4. So we're going to take this and we're going to work that out. So here we go. 3x minus 5 is less than or equal to 4. I'm just going to solve this. So I add 5 to both sides. Anyway, this is how I would do the problem. 3x is less than or equal to 9. And then I would divide both sides by 3. I don't have to do any flipping here. And I think I'm going to picture it on a graph. And it says less than or equal to, so I'm going to color it in. And then less than goes to the left. All right, so all the colored, all the shaded values are solutions. So back to the question. Tell whether the given number is a solution. We're looking for solutions. Solutions are shaded. Solutions are shaded. So first one, 5. Is 5 shaded? Nope. Therefore, it's not a solution. So no, it's not. Second one, 0. Where would 0 be? 0 would be down here somewhere, right about here. Would that be colored? Yep. So that is a solution. It's a number that will work if you plug it in. Next one, negative 1. Negative 1 would be down here somewhere. It would indeed eventually get colored in. It would be shaded. So it is indeed a solution. It will work in here. If you plug it in, it will actually make it true. And the last one, 4, is right here. It is not shaded. That means it will not work. It is not a solution. All right, I hope these notes are helpful. Good luck.